Okay, secondly, this video will be a little bit longer. How to tell from a motion graph, both position versus time and velocity versus time, if the object is speeding up, slowing down, or remaining constant. So let's remember, on a position versus time graph, it's all about the slope. So that means if the slope is increasing, that's what this up arrow means. Increasing slope means increasing velocity. Remember, whatever the slope is doing, that's the same thing the velocity is doing. So if the slope is increasing, the velocity is increasing. That means it's speeding up. Some people don't know what an increasing slope looks like, though. I found this a lot in the classes that I've taught, that I'll show people a graph that looks like this, and I'll say, what's happening to this slope? And many people will say, it's increasing, it's going up. This slope is not increasing. When you think about the slope is really just about the steepness, if you can even say that's a word, the steepness of the line. Think about if you're like walking up a hill, right? If this is a hill that you're walking up, think about the steepness of that line. As you go up this hill, does the steepness of the hill change at all? I think it's easy to see. The answer is no. The steepness isn't changing at all. And if you were to calculate the slope of the line here versus here, you would get the same number, because this is a straight line. So you need to know that any straight line is a constant slope. Constant slope. Straight lines have a constant slope. And if the slope is constant, so is the velocity, on a position versus time graph at least. And a curved line is a changing slope. So anytime you have a curved line on a position versus time graph, so let's say right here, if this is the line, for instance, what I can actually do, if you don't understand why this slope is changing, if I choose these 2 points and calculate the slope right there, if I blow those 2 points up, that line at that point will be basically a straight line. And I can do the same thing with this one, blow it up, and it's a straight line. And you can see that these two lines do not have the same slope. This slope is gradually changing. It's actually gradually increasing. The slope is getting higher and higher because, again, if you think about walking up a hill, it's easy here, but it gets steeper and steeper and steeper and steeper and steeper. Okay, so that's what we're going to be talking about with position versus time graphs. If the slope is changing, that means the line is curved. That means the speed is changing. And specifically with an increasing slope, any line with an increasing slope will be getting steeper. So if the slope is getting steeper, if the line is getting steeper, that means it's speeding up. Let's draw the two that you could see. If it's a positive slope, remember positive slopes go up and to the right, but it's not going to be a straight line now. It's going to get steeper as we go along. So all of these slopes are positive, but they're increasing. It's going up and up and up. It's getting steeper and steeper. So that's positive direction, positive slope, but increasing slope. Positive increasing slope is a positive increasing velocity. And then if we're going in a negative direction, down and to the right, instead of a straight line, we want to get steeper as we go. So the line would look something like this. So again, imagine that you're walking down this hill. It gets steeper and steeper as time goes on. That is a negative increasing slope. So both of those depict objects that are speeding up. Slowing down would be a decreasing slope. If the slope is decreasing, that means the velocity is decreasing. If increasing slope meant getting steeper, well, now the line will be getting flatter. It gets more and more flat. So again, let's draw our graph. So positive first. So let's imagine the graph starts out like this. And then imagine as time goes on, instead of a straight line, we want it to get flatter and flatter and flatter, so it would look something like this. So that's a positive decreasing slope, which is a positive decreasing velocity. That object will be slowing down, moving in a positive direction. Negative, again, instead of a straight line this way, we want to start out this way, but I want it to get flatter, or sorry, not this one. We'd start out this way, but I want it to get flatter as we go. So instead of staying that way, we're going to go like this and get flatter and flatter and flatter as time goes on. There's our negative slowing down slope. So this slope is negative and decreasing because it's getting flatter. So those are the curved lines that you could see. If a position versus time graph has a curved line, that's changing speed. But if it's a constant slope, that means you have a constant velocity. Whatever's true about the slope is also true about the velocity. Constant slope just means you have a straight line, and I've already said that. Straight line as in not curved. All right? If there's any straight line, that's a constant speed, and that's this graph that we had here at the beginning. All these lines are straight. So at each of these individual segments, the speed isn't changing. Now the speed changes when this slope changes, but there's no curved lines there. To move over to the velocity time graph, we're going to switch from thinking about slope, and now we're going to think about y value. So instead of an increasing slope, we got an increasing y value, means increasing velocity or speeding up. And then actually, we can just go ahead and put that on all of these. Decreasing y value means a decreasing velocity, and a constant y value means a constant velocity. So let's go back to the top, talk about increasing y value. It's not going to be getting steeper. Slope doesn't matter here. This is not about slope at all. Instead of that, increasing y value means, and we talked about this earlier, it means that your y value will be going away from 0. So let's draw our graph and see the two types that we could have. On a velocity time graph, I think I said this already, there are no curved lines on a velocity time graph. So positive velocities are up above, and those are the easiest ones to see. This line is clearly going away from 0, so it's speeding up. The object is speeding up. And these y values down below are also going away from 0. So both of these objects are speeding up in a positive direction, speeding up in the negative direction. Decreasing y value. Instead of going away from 0, these y values will approach 0. Approaching 0. So we can draw the two lines that we might see here for a velocity time graph. Positive velocity, where the y value approaches 0, looks like this. That's slowing down in a positive direction. Negative velocity, where the y value approaches 0, looks like this. That would be slowing down in the negative direction. So, going away from 0, speeding up, approaching 0, slowing down. Constant y value means any horizontal line. And it can be anywhere on the graph. It can be up here, it can be down here. Technically, it can be right in the middle. You still have a constant speed if your velocity is 0, it's just that you're not moving at a constant speed. All right, so that's how to tell whether the velocity is increasing, decreasing, or staying the same with these two graphs.